So welcome back, everyone. Thanks for filling in the Mentimeter. I'll just check the first two questions for now, and then we've got a few more questions coming up in Craig and Vinny's talk. So interesting to see how many people have made changes to their assessments due to AI. Obviously, this varies on what kind of courses you are teaching. So we had 8 people preventing AI usage, 10 for both preventing AI usage and encouraging it, and 20 for no changes so far. And for incorporating an AI coach into their teaching, well done on the 3 people that have already done this. I'm definitely in the no, but I would like to category, which seems quite popular and interesting to see other people or a hard no for now. So we welcome the next speakers, Craig and Vinny, also from the University of Glasgow. I will let you share your screen. Thanks.
Perfect, thank you. Can you see that okay, hopefully? Great, thanks. So thank you for having me today. So I'm probably going to go off on a mild tangent from what the rest of the discussion's been so far. Discussing generative AI, I'm probably going to look at everything else, but Vinny will pick up on generative AI for the second half of this talk. So today I'm going to discuss how and if basically we incorporate modern technology and techniques into the statistics curriculum, and a bit in how to educate the educators, as it were. So the first question is, should statistics embrace new technologies? My view is yes. I'm an advocate of this, but there are some caveats and there are things to consider. And I'll basically spend my part of the talk discussing these different things. One of the main things for me is if this enhances the learning and the skill set from our students for what they will face in the workplace, then that gets a tick for me, and that has some real world relevance. Not a fan of doing things, I guess, for the sake of it. But the big thing is integration. Any kind of modern advancement or new methods we introduce should have some solid integration within the current curriculum. And I'll add a warning here, I do not propose any radical changes to how we deliver our programmes, but basically how do we kind of modernise in an effective way. So in terms of students, if you look here on the right, this image, this is just a big list of some different tools that we have here. Quite a lot of these are quite key for employability. If you take a search in LinkedIn in any kind of data analytics, statistics, or data science role, you'll see a lot of these things come up and they'll be used. But we don't want to shove everything at our students. We don't want to overload them with a ton of methods and with kind of little to no motivation. Also looking at how we teach responsible use of our less trusted, as it were, technology or generative AI, how we can effectively encourage students to use this, and Vinny will talk more to that within the second half of our talk today. One of the first things as well, though, is how are these more kind of modern or newer approaches used in practice, looking across industry, academia, particularly in civil service and government too, and how this is done. So some general views, mostly my own. Do correct me if you think I'm missing the point with some of these, but the uses of new technology in practice, I find just from speaking to kind of colleagues and friends, within industry, there is a bit of a focus for some of your in-demand tools, some of your more common used things, such as, I guess, TensorFlow is a good example. There's a lot of cloud computing I found, so things like Azure, and how we use cloud computing resources, and I guess more of a discussion on how you ethically use these. Use of generative AI, that seems quite common, encouraged, and of course version control as a good means of standard practice. Within academia, as I've found over the past few years, definitely more of a shift to creating a more kind of positive environment around reproducibility. So using things like GitHub in terms of kind of paper writing, sharing code and resource practice. I feel there's quite a positive shift in that sense. That's something we're moving to see more of. A bit more of an emergence of your kind of deep learning and AI approaches within statistics research. These are coming up more and more. So these methods are being used by staff. So there is knowledge there within departments across statistics. Kind of within your government civil service branch, there's perhaps more of a focus on transparency and work. Again, maybe reproducibility, but more transparent with how things are done. Security is a big thing. Probably R, I would say, is still the primary tool here, using a lot of classic statistical methods. Again, highlighting that these should not go away or be sidelined, they should still be key. So I guess our questions are, how do we decide what we want to cover? And if we cover these things, how do we do this? And also, how do we adapt? And how do we learn and kind of train ourselves as staff how to deliver these modern approaches? So I guess I'll start with one thing that's evolving and that we tend to adapt to, which is R. So many institutions with a statistics curriculum will use R as their primary programming language for teaching stats. The use of R has grown quite massively, the functionality within R within recent years or past decade or so, particularly the emergence of RStudio, the Tidyverse library we see everywhere, things like Shiny and R Markdown. So there's a lot more functionality within R, also a lot more compatibility within RStudio with other languages such as Python and Julia. Some recent changes that have happened that we have adopted to, at least within Glasgow to some degree. So Quarto is a good example. This is effectively, I say, a quote-unquote update of R Markdown. It's a nicer way of using R Markdown. It's easier to use. It has a bit of a cleaner integration with Python and Julia. Has some more advanced features than this, is like developing web pages, for example, in notebook formats. In Glasgow, we've started teaching Quarto across our honours and masters programmes. Shiny, this is now compatible with Python. It's something we're kind of looking at towards the future, which I'll get to as I go through this talk. And Tidyverse, it just changes all the time. Every time I go back to use it, a function's called something different, and you have to kind of constantly update and recycle these things. I won't lie, that one was more of a bit of a personal gripe. But it does change, and we do adapt with it. And most of these, if not all, are changed within statistics curricula, and we do this regularly. So we are good at adapting to change, and we can learn. So I don't think there's an issue or kind of hesitancy in our ability to adapt to these things. I guess our question is, what should we adapt to and how do we do it effectively? One of the first things is programming, I would say, particularly Python. If you go, Python's everywhere, basically. It's probably the most demanded thing from, say, our industrial advisory board we have within the school. We've adapted Python to some of our programs now and looking to do more so in our honours curriculum. So it's almost kind of like step one of this modernisation. And the case is very strong. There's a massive industry demand for this. It's a lot more suited to some of your ML and AI style problems and modelling. But we have to consider quite carefully how we integrate this. I'm not a believer in you simply teach a Python course and move on and that's enough. To be fair, the students can say they know Python, but we want to give them the experience to go straight into the workplace and know how to use this with the methods they've adapted. So teaching Python, yes, it's a good thing, but I think we have to look at it at a programmatic level and how we kind of deliver this. So that leads into multi-code integration. As you can see, this image that Vinny kindly made that Jenn showed earlier. This is quite a popular image amongst us. It's one of my favourites. So in order for students to learn these technologies, integrate them consistently through a programme. And this is something we've looked at recently when reviewing some of our programmes in Glasgow and how we can do this and what the challenges are. So a current debate that we have is how much integration is needed. Should we be doing this for every course? Should it just be for some? I guess we're kind of in somewhere in the middle. We think we should integrate as much as we can, but there are some examples where it's possibly not useful. Um, there's some methods and approaches that are just more suited to using R over Python. A good example is probably things like additive models, though you can use these in Python. I do just believe the package is probably more maintained within R and more common to use. Conversely, there's some things that are more suited to Python use, which we'll go into touch on to later as well. But I think there's other things that sit quite nicely in the middle, and you can use across both languages quite easily. Good example to this is just regression, for example. This can be easily adapted in both cases, and is there any issue with us kind of demonstrating how to do both within a course? So one way we've kind of looked at this and have adapted in some of our courses thus far, particularly our master's courses, using the accessible notes we've had developed by our learning technologist in the department, is this idea of a kind of code switcher. So these are HTML notes, and they allow the user to effectively select between the language they want to use. So we've adapted it in different ways for things like version control, but we've now used it for multiple languages. So here we can look at how this works with R and Python. So for example, here, if I show you here, this is the switcher. You can effectively just select between the two options here, the language you want. Currently in R, loading in some libraries, and then we can just switch to Python just like this. So we've used this, or I've used this in one of my courses as an example for looking at regression and how to use R and Python for both. I think in terms of a format for presenting this to students, it's worked quite well. It just keeps things quite neat and avoids things getting a bit complex. So this is one solution we have for now, and something we're looking to continue rolling out, just in terms of how we teach and deliver this content to students. So I guess with multi-code integration, we have a few things to look at. So in terms of the good, students get exposure to both languages in the programme. They have a familiarity with both. There's not one dominant language as such, and the optimistic thing is they can be fairly competent in both languages to use. Of course, there is a question of potential student overload and how we kind of deal with this. If we're enforcing teaching both at the same time within a course, like in terms of assessment, or are we providing this as just a resource and we'll focus on one through a certain course, is a different debate. One of the problems, I guess, is how many staff can efficiently code in Python to do this. There are some Python users within our school. I put myself probably in the middle as a intermediate one. I pass my knowledge over to Vinny and Jenn in that sense. I think they're a lot better at it than I am. But some people just don't use Python at all and will use R. And then one question we have though is, do staff actually have to learn Python depending on how we're delivering this? Guess it depends on the course. For example, in a course teaching linear regression, this is a fairly straightforward thing to compute. This is something a postgraduate, for example, potentially create. But in some courses, it may be a bit more difficult. If you're using more advanced methods that may involve some time looking at things like, say, spatial modeling, for example, how well does that translate over to Python? So there is a kind of yes and no, and it depends. And how do we support this in terms of resourcing? How do we take the burden off? Because I guess it's a fair amount to ask people to learn a completely new programming language, so we want to try and strike a balance. Another thing to look at is version control. If you're at a talk a month ago, I spoke about this extensively. I'm not going to do that again, but I will just give an overview. So this is becoming more of a prominent skill within industry and in academia as well. Use of version control is increasing for code sharing and just general good reproducibility practice. So we look at how we can integrate teaching version control into our practice. And as I spoke about a month ago, this is some of the things that we've done within Glasgow. in version control. It was designed for all learners, so staff and students as a general resource, and we've got this taught across several programmes. Using version control in assessments, I found this is really good for group projects. It fits quite nicely into that style and kind of encourages good group work. Also within programme design too. We can use version control to share some course materials within some of our programmes. It's a good way of keeping a general resource hub for managing these. It also integrates nicely with our accessible notes I was talking about earlier. I guess there's a similar issue here with learning Python with staff as well, though we've been a bit more at the forefront of delivering kind of training in this with the short course. We feel it's worked generally well. People seem quite on board. Quite a few staff, I think, within the school are using version control within their research and also within some of their teaching practice as well. So this one I'd say is moving quite positively. And again, though, has the thing with Python of taking the time to learn this, and that can sometimes be a bit of a difficult thing for us to find. Next, I'll touch on machine learning. So machine learning, again, it's a big industry thing. There's a clear demand there to kind of cover these approaches. How you define machine learning can be very broad. It can be some of the more simplistic end of things, stuff we already teach within our statistics curriculum, but can get into some more complex algorithmic methods. One thing we don't really we want to avoid is trying to teach a black box style course of here's a method, off you go, use this. We want to try and explain how these methods and models work, and more importantly, when it's best to use them. So don't run to random forests when a logistic regression could do the job, for example. Something simple. And again, a way of motivating that, I think, is beginning to teach your more classical stats approaches, your regression-based things, going into classification, to motivate the use of more advanced ML approaches and algorithms. I think it's probably the better way of doing this, but it's then a case of where and when does this fit within your curriculum. And I will touch on some things to think of shortly with this. In terms of coding, R can do quite a few of these things with machine learning, but it depends on the approach and the method, because Python can be better. In R, there's the Tidy Models package from Tidyverse, which is getting a lot of kind of more addition of more ML approaches within it, and it seems to be working quite well as a potential new R solution. It's the closest behaviour to something like sklearn, a bit of a mimic of that in a way. So yeah, you can potentially use both. I think it depends on the approach and method you're covering, but you probably want exposure to both different methods. I'd say looking through industry, it's probably more prominent to see these things adapted within Python. Again, we have the question of how much do we cover? There is a host of different ML approaches out there. How many courses does it consist of as well? Is one course sufficient? Do we have to have multiple courses? Again, all different questions to think about. Then on to AI. This is a bit, it's like machine learning, I guess, but all skill and probably something we have a bit less of a knowledge base within. So you're adding in new different skills here, like computational scaling, and learning when to use different AI models over classic methods. Again, labouring that point of adapting these things for when they're most suitable and not just using the fanciest approach at all times. I think is an underpinning in a lot of these things when considering design. In terms of coding, Python wins this one in my debate. You can integrate it with R, but it's tough. I can attest to trying this a few weeks ago with Vinny, actually, trying to get it to work in R, and it was horrendous. They just don't communicate with one another because you're effectively calling Python to run things like TensorFlow, and it just can cause headaches. So there's probably a prominence here to utilize Python when using AI methods. In terms of what to cover, there's a lot to cover, and there's a massive danger of potential overload here within the curriculum. if we adapt to cover too much. For example, computing science, for example, will teach quite a lot of different courses in AI, but they're split across 4 to 5 modules. So we should think how many modules in this we want to deliver, or should we focus on a particular suite of AI approaches? So again, that leads into some of these challenges and how do we teach these things. In my view, I tend to avoid this kind of black box approach of here's lots of different methods, off you go, use them, have some fun, but provide a motivation in when, where, and why to use these approaches and how they can be an effective alternative for some of the more classical statistics methods we cover. How much do we teach? I've mentioned this. If you covered some common deep learning methods, you probably need about 4 courses. And that's probably an optimistic guess. So maybe having 1 course in this isn't the best idea, or it should be tailored to something very specific. There's the staff expertise in this, how much we all know about some of these methods. I'll claim to have a very passing knowledge in this, and I'm delivering a talk discussing these, by no means an expert. So there's a challenge there as well in terms of the expertise that we have within our departments. And then last point, I guess, in staying relevant, there's quite a lot of evolution in this field, a lot of new approaches and methods coming out all the time. Can we keep up to date with this? It's quite a challenge. It makes it a bit difficult to think of. So, but these are things I think that have to be considered if we were to try and adapt these things within a statistics curriculum. So I'll just wrap up here with leading into Vinny's talk regarding generative AI as well, and how and whether we should teach generative AI. This has quite a lot of the same challenges that I've just mentioned in the last few points, but it does seem to be quite a significant part of our lives as we move forward. So I'll pass over to Vinny to talk about what we're planning. I think as Jen mentioned before, there are a couple of follow-up Menti questions as well, just based on what I've discussed, so feel free to answer those. So I'll just leave us for a second and then pass over to Vinny.
Cool. I'll just try and share my slides and hopefully we'll have the same, should be able to have the same PowerPoint. Where am I? Yeah. So I just need to full screen in a second. Cool. Can you see full screen hopefully? Yep, great. Okay, so there's the Mentimeter and I've unmuted, so great. I'll start. So I just wanted to sort of start by clarifying kind of what we mean by teaching generative AI, because it's kind of different takes on the same set of words. So some of my colleagues would love to teach kind of generative AI in the sense of generate an image, generate some text, teach what an LLM is. That's definitely kind of not what we're aiming for, at least in kind of this aspect of what we teach. When I mean kind of teach Gen AI, I'm kind of talking about teaching people how to use tools such as ChatGPT. Now, I'm kind of very aware that this is maybe not something that's completely, in any sense, done and dusted, and it's very unclear, for instance, what properly means. So how do you properly teach something when you can't even define properly? And how do you do this in the context of statistics? But we're going to sort of give it a go if we can. So, I mean, I guess the reasons for teaching Gen AI are maybe a little bit different than some of the stuff we've talked about, but it's kind of related. So policy at many institutions allows the use of Gen AI. So in Glasgow, there's a mix between different schools, programs, even within the university. Some allow it, some don't allow it, and there's kind of a requirement to essentially acknowledge that you've used it. Either way, our staff and students are using it, whether you want them to or not. A kind of blanket ban seems a little kind of pointless and kind of backwards, at least in most cases. Especially when kind of we think about students when they graduate, they're very likely to be using this. I mean, if they're going to a data science job, they're very likely to be using ChatGPT in some format, whether that kind of be Copilot integrated into whatever coding platform you're using, or just querying via ChatGPT. But what we need to teach them is kind of the issues. So if you have a look at my image on the right, you might notice two, at least to my eyes, two major issues. One that hopefully should smack you in the face, and one that might be a little bit more subtle. Just give you 1 second to have a quick look. So you probably noticed I've clearly used an outdated Gen AI because it's done absolutely terrible at the writing on the screen. But you might also notice a slightly more subtle one that I asked for a university lecturer. So of course I've kind of got a 50-year-old white man, which is kind of maybe which seems maybe fine as kind of a one-off, but if I was to do this 100 times, I would suggest that I might get quite a lot of those being 50-year-old white men or slightly younger white men. So currently, in terms of our students and Gen AI, our students are essentially using Gen AI badly. We took some inspiration from a talk that Michael gave in Glasgow last year, I guess it must have been. And we implemented a traffic light system, which basically sort of encouraged them to use it for some tasks, but made it kind of very clear they weren't allowed to use it for, say, the exams. This seemed to work relatively well. We had less issues with the exams. Students more openly kind of used Gen AI, which I think is better than them trying to kind of minimize the screen as soon as I walked up to them. So at least to me, that seemed like a positive thing to do. Students don't understand how to learn from it, though. We tried to provide some advice, but it was very much off the kind of, I think it was off the top of my head about a couple of days before the start of the course when we realized maybe we should kind of give them some advice in that respect. And what we find is students just tend to throw entire questions into their favorite tool and don't really check what comes out. And that doesn't really help them when they try to move on to doing, say, a dissertation or working in industry. It's not just students that are using it badly, staff are using it badly as well. You can question how good my images are as to whether you think I'm using it badly or not. Again, staff are using it. There's not much we can do about it. But we need to basically teach them where they should and shouldn't be using it, because not only are they maybe not using it inappropriately in some cases, but they're also probably not using it where they could actually get quite a big advantage from using it. But again, like the students, most of our staff probably don't have much of an idea what it is. Definitely most of them would have no idea on the theory. Some of them might have used it a little bit before, but they frankly won't have the intuition to do that well. And it's also potentially useful in a research context. So I'm kind of quite research focused. UKRI does allow Gen AI within research applications. And I know professors who already use it to write grants. Whether you think that's a good idea or not, I guess that's maybe where me and Jen might disagree. I don't think that's a great idea personally. But industry, from talking to people in industry, you kind of get at least I get two kind of main reactions. One is kind of encouraging its blanket use to keep the competitive edge. Again, whether you agree that gives you a competitive edge is maybe kind of questionable. Others are kind of outright banning it. They're basically worried about the consequences. And basically, either way, they don't entirely know what they're doing unless they're real specialists in the industry, which is kind of few and far between and probably not related to kind of statistics and data science at a kind of broadest level. And from what we've seen, at least, none of them really seem to be thinking about kind of documenting it, like documenting how it's being used, thinking about the long-term implications of such practices, or kind of the safety aspects, like what they should teach, what they should essentially teach is maybe the wrong word, what they should basically be educating their kind of staff around where and when it should be used. So we're kind of developing this course, and we've got about 20 companies that have agreed to help us in some capacity. Basically, we're hoping essentially they're going to fill in the gaps of things that we've not thought about, things that we're, as I said, definitely not experts in. So at least that's our kind of plan. So what I'm going to try and give you now is kind of an overview of kind of where we're at and what we're trying to do. So this is our team. This is, I think, ChatGPT or Gemini's attempt at our team at the top, and this is my attempt at the bottom. You might notice an amusing blend between Craig and Jen on the bottom right, which I'm guessing is meant to be Jen, but the name seems to have blended into the two. And you may notice that I've got slightly less hair than in that particular image. But as I said, we're not experts, but we think we're in a position where we can potentially help people and potentially help people know how to use it and basically evaluate its own use. I will say Jake, who's not here today, is maybe an expert. I mean, he does a lot of kind of natural language processing. He knows how LLMs work and that kind of thing, whereas myself, Craig, and Jen probably don't. Yeah, we think we can help. Our school certainly seems to think we can help. I think they've probably got more confidence in us than we do. But we're trying to see what we can do to kind of help both students, staff, and kind of beyond. So the course that we're trying to create is basically designed along the same lines as the GitHub course Craig has talked about before, and a little bit today, where we're aiming at kind of multiple different cohorts. So we're aiming both at students, staff, and industry in this case. So we're not trying to restrict it. We're trying to make multiple uses of the course because we think the skills are somewhat interchangeable. The one thing we're trying to not do is essentially not teach the theory of neural networks or the theory of large language models or anything along those lines. We're not aiming to require kind of any maths knowledge or even kind of statistics knowledge, almost to an extent, maybe a little bit. It's just not what we want to teach. And we're not trying to tell people where they should and shouldn't do Gen AI. What we are trying to do instead is we're trying to encourage people to think about what they're doing with Gen AI, trying to get them to self-evaluate their own use and basically understand where and when it makes sense to use Gen AI. We want to give them a little bit of intuition here, maybe kind of help them around the ideas of where and when it might be useful and what it's actually capable of doing and what maybe it's not so capable of doing. So we came to the conclusion of splitting this course into kind of 4 key themes. I'm certainly not going to say these are perfect, so any feedback is very much welcome, either in the chat or Craig and I's emails are at the end if you do have any further thoughts you'd like to tell us. So we have 4 themes. So the first is kind of education. So as I said, this is not teaching the theory, but this is just trying to give the ideas of kind of Gen AI, like strengths and weaknesses. So we've got development. So this is around kind of learning, developing, how you might use it in kind of practice. Third one is reporting. So this is aimed at the individual user. So the idea being here to think about kind of what you might put down in a document about how you've used generative AI. Did you use it to create the code? How have you unit tested it, as Jen was talking about earlier? And kind of basically thinking about what you've done and what the after effects of that might be. And then the final one we've got, which is kind of primarily came from kind of initial industry feedback, was this idea of safety. So this is more from the point of view of kind of a manager or an organization looking down, trying to suggest either guidelines or what they should be kind of teaching staff, what they should be telling them when they shouldn't use generative AI. But as I said, if you do have any feedback, we really would appreciate it. As I said, we're certainly not experts. So in terms of each of our topics, each of our key themes is divided into 3 bits currently. Again, open to change. The idea of these are kind of prompts, as I said, rather than trying to directly educate people. So prompts to kind of encourage people to self-evaluate. So the first one is around kind of how does it work? So essentially, basically the theory of trying to use text as data, and then how essentially the language model can learn where it can get its information from, whether that be kind of illegal, legal, or semi-legal, depending on what you think and which Gen AI bot you're using. What are its limitations? So again, this is not maybe thinking about not trying to get this too specific into this particular version of Gen AI, but more trying to think around ideas of kind of ethics, diversity, hallucination, biases. So I talked a little bit about kind of gender biases within images, and you see that similarly with race and other things if you kind of ask the right/wrong thing, depending on how you consider it. The other thing is just sort of staying safe. So this is kind of thinking about critical evaluation, fact checking, limitations, and essentially long-term data corruption, because I think this will become more and more of an issue further down the line. It'll become a very interesting kind of research topic as well, for sure. Well, I think it already is. In terms of development, we kind of wanted to think about the kind of learning strategy to start with. So if I wanted to learn, say, about deep learning, for instance, and I only knew kind of linear regression, how would I kind of go from one to the other? So asking ChatGPT, tell me about deep learning, probably not the optimal strategy. Instead, a step-by-step approach is something we're more trying to encourage and get people to think about. Development is kind of more along the lines of kind of prompting. We don't want to get into, oh no, not quite prompting. So this is about how to use it to generate, say, a data science project or a statistics project. So again, this is thinking about maybe not jumping straight to give me 2,000 lines of code that does this, and more thinking about kind of step-by-step building through. And then the effective usage is a little bit about prompting, but we're trying to avoid getting into kind of prompting literature that is going to get outdated. So, you know, like, so maybe a year ago, there was a well-known prompting strategy that if you basically asked the Gen AI to write you code like Elon Musk, then it would write you really good code. Similarly, if you asked it to kind of write you a code to play a game, then it would probably, as Elon Musk, it would probably give you something terrible, given he clearly can't play games. But you know, we don't want to go into that level of specifics because it will get outdated or controversial. But we just want to kind of give some general guidance here. In terms of reporting, we're kind of thinking this is something we're probably less clear about what we want to do. But I guess I foresee problems where people build generated code into systems, into data analysis platforms, and it causes problems in the long run. I've even heard suggestions that we should stop teaching people to code, which, as far as I'm concerned, is wildly the wrong direction. But essentially what we want people to do is to write down what they've done, what they've considered, and basically think about how they might keep track of code that's maybe not as reliable, potentially more reliable in some sense, potentially less reliable in other senses. The other thing here is kind of regulations and reporting. So these can be internal regulations or external regulations. What do you need to be aware of that where your code might lead to? And the final one here is kind of ethics. So this is kind of thinking about making sure people think about what essentially the side effects of their use of generative AI could be. Like, where could this code end up? Where could this model end up? What potential ethical issues could come into this that we're not thinking about properly? Which is probably something we should do generally that we probably don't do as much as we might like. So finally, this is kind of from an organizational perspective, so safety. So we're kind of talking about kind of education. What does staff need to learn? So I mean, this is where we're at with kind of our school, for instance, is we need to work out what do our staff need to learn to be able to use this effectively, not make mistakes, identify issues with students using it, that kind of thing. Risks, so any specific risks. So for instance, if you've got clinical data, that kind of thing, being aware and making people aware of whether they should put that data into leaky Gen AI bots, probably not. And then similarly, kind of what processes and documentation you want to put in place. And I guess more importantly, how are you going to ensure people read and adhere to these? That's something I'm really not sure how you do. I mean, I've not read our university AI regulations, put it that way. So the way we want to deliver this in person is through a worksheet. So the worksheet will be divided into four bits, 4 sections, each with 3 boxes. And the idea being that if in person, you should take a task from your work and you should fill out the boxes and basically think about what you might want to consider in that situation. And I can see a scenario where people might use this as an overall kind of project evaluation in terms of how they might use Gen AI. We're also talking about potentially having a MOOC for this. A little bit worried about people accidentally putting sensitive information into a Coursera platform. So we're going to aim instead there to use a much more generic task, you know, fit a regression to was it predict laptop prices was the previous talk. So something along those lines. So we're hoping this essentially allows us to help without giving definitive solutions. One of the kind of professors at the very senior professors at the university was very concerned at the thought that we might be offering kind of more concrete advice than this, which wasn't ever the intention, but certainly something we've scaled back even further now. And we're hoping this will also future-proof it a bit, just to be a little bit less specific to individual things. Finally, just a quick overview of the different ways we're intending on using this. As I said, we always like these courses to be available to multiple kind of cohorts. So we've got our students, this is our undergrads, our postgraduates, our postgraduate researchers as well. Our staff, we're kind of looking at offering training and potentially spreading that further around the university and to other institutions. Workshops for industry, want to kind of make this available and more widely used, and we're kind of open to different ways of doing this. And I guess finally, we're going to create a kind of MOOC, which we hope will make this information a bit more widely available. So I'll finish there, so I can see comments in the chat, which I've not had a chance to read yet, but we would really appreciate your feedback either in the comments here or by email. So reach out to any of either me, Craig, or Jen would be absolutely perfect. If you're interested in seeing our slides, they're available on my GitHub.
Great, thank you very much for the nice talks, Craig and Vinny. We've got a few bits in the question and answers and some good comments as well. So Alan noted on the data security point that Coventry University uses Microsoft Copilot, which ensures no information shared with Copilot is shared outside of the institution, and quite a few other institutions appear to be using this. So this is a really good top tip for us. And
so we also have the same thing. I guess call me a cynic and say that I'm unconvinced that doesn't mean there's any data leakages. I mean, I think unless you install your own LLM on your own computer with a lot of locking information, I wouldn't consider that data to be particularly safe. But then someone did make the same argument about OneDrive, which was valid, that I'd not thought about.
We also had a question from David, if you could expand on how people can use it safely if they don't understand it, because it's quite a black box between the prompt and the output.
So I guess that's kind of why we wanted to have this kind of self-evaluation type platform. So if you're asking, can they use it safely? I think the answer is probably no, right? Can any of us use it safely? I would hazard to guess the answer is probably no. I think if you were to, the more and more you think about it, the more chance you have of using it safely. And I guess that's what we're aiming for with this kind of thing, rather than trying to kind of guarantee any form of safety, is just to try and put in sort of system in place that might at least help a little bit there.
For sure, I think teaching a small basic understanding of what they're doing, so generating the next token, for example, the avalanche safety report, it does generate a very nice looking safety report, but it is just based on probabilities. It's not actually looking at the data. So in that case, it would be better to Google and just teaching how to test the outputs. So even if you asked a colleague to write this code, how would you know the code was performing well? So you still want to perform these kind of checks. And then I will quickly share just the Mentimeter for the last few questions. So we asked, have you incorporated version control into your teaching? 7 people had, 7 people no, but I'd like to, and 20 people hadn't. I guess it's quite dependent on your course. Maybe you're not teaching coding. But yeah, it's great to see that some people are incorporating this into their trainings. I do think it's a great skill for our students to have. And what other technologies you added or would like to add into your teaching practice? So we saw LLMs appear here and generative AI in general. And a few tools that I haven't heard of, such as Symbolab and GeoGebra. So I'll be checking those out after this. And we also asked, how should we train educators to use and incorporate generative AI into their teaching practice? So we've got some really nice answers there, like we need some workshops, having groups and collaboration, showing lots of different examples. I find that really helps for my learning. And learning from our students, because actually they're becoming quite effective users of generative AI. And I'll quickly pop in the chat a link to our workshop in Edinburgh, which is about generative AI and education. So the sign up link is there if anyone is interested. We also have a question from Scott, I think, in the chat. Yeah, we should catch up. Great. Do you have any further questions for any of our speakers? No, I will pass back to Kevin, hopefully right on time. Thank you all for coming.
Right, yes. Well, thank you very much for everybody giving a talk there. I'll give a clap there for the recording. Thanks to you, Jen, for organising all this. It's very interesting stuff. Yes, I mean there was a number of things we didn't really get around to. I couldn't put anything into the chat to ask about, or other than to the Q&A to ask about the different AI things available at the moment. Some of them you can pay for something to get a better version, right? And we didn't really discuss about, you know, how some students will be able to pay their way to being able to, you know, get a good mark. Yeah, does anybody have any
for sure.
points on that?
I have actually marked some reports where I could tell if a student had paid for a better version. But yeah, for sure, it's a problem equality-wise, but there are also studies that show just by having access to an AI tutor, then both students can improve.
It's definitely an issue. I'm not convinced it's like a huge issue. I can't imagine the grade disparity being massive. Obviously, any disparity is not ideal, but I'm not convinced that the difference is going to be huge.
I think a part of the problem, I guess, with the studies is because it is constantly evolving. By the time you've probably done a study, the current free version was probably the paid version from the last time, which makes it really difficult to almost quantify in a way. But yeah, I think maybe a year or so ago, I would agree with Jen that you can see a difference. Like, I guess from ChatGPT, it's now that the current version is now what the paid version was about a year or so ago. And there is a notable difference in terms of what it can do and what it can handle. And yeah, I guess it's hard. It's very difficult with something that's constantly evolving. To kind of kind of quantify that effect.
As I say, I paid for ChatGPT about 30 days ago, and within about 15 days, I changed to Gemini because it seems to be better. So I think that's kind of the speed at which we're moving. That essentially, well, wasted half my 20 quid, arguably the whole of it, depending on what you think. But you know, and then I'd stopped using it basically by week 3. So.
I think as the free tools evolve, it will be more down to the students prompting and their usage of AI rather than which model they have. So hopefully it evens out a bit more.
Well, it may even out, and it maybe that there's not much difference between them, but there may be the perception amongst students that, well, actually there's some other students who are being able to pay for these much better models, right? There is that kind of, for some students it may feel very unfair, even though actually maybe it's not a huge difference.
For sure, there's been discussions on whether like the university should pay for the pro version, but then there's so many different models coming out now. Like, which version do you pay for? Do you want pro ChatGPT, or do you want to put money into Gemini? So it's a difficult problem for sure.
Indeed. Okay. Right. Well, anyway, that was my question. So, should we wrap it up there then? Yeah, I'm getting some nods. Well, again, thank you very much for great set of talks and a lot to think about. And I am sure that next year we will be doing another workshop on similar Gen AI things, because as you say, it's something that evolves very rapidly. So I think we'll stop it there. Thank you very much.
Great, thank you very much.
Thanks, everyone.
Thanks a lot, everyone. Thanks for joining us.